Java by example, and we are still looking at the multi-layer perceptron, and today we're going to continue with the translation from C code. Last time we translated two functions. We translated the constructor and the populate input, which wasn't that much code, and then we translated the calculate network that will prepare each of the nodes in the network. And today we are going to look at training the network, which will change the different weights inside of the network, and also translate the recall network, which is the function that takes input data and tries to get the actual answer from that input data. And that function is a bit easier to grasp, so I think we're going to start with that one. So let's look in here and copy the code from the recall network. It's pretty much straightforward here. This is not used anymore. Now we have an amount of data instead. So we change this to some int values of data. We have a calculate network. We have a winner, an index. We have some output neurons. And then I think most of these should just be system out. Print line could be used there. We can use print line here as well. And here I believe that we can't do multi-line this way. So I believe we just have to do the actual multi-line by adding the phrases. I think that could be a solution for this. I'm not sure what the correct solution should be. See here, add the plus over there instead. So here, do some more values. I see. You want dashes on, so you frame each of the different values as well. I see. So let's continue with addition here. Thank you, IntelliJ. Please do not make so many intelligent presumptions. Kind of hindering my progress here. So let's get into the flow, will you? It seems to. So there. Okay. And then we have a lot of numbers. So this file number should actually be inside of here. I guess there is a way to do this. And we actually don't have any file number. So let's just say here that we have a string value that takes a bit the file name. So we can use that in the output. I guess this function will actually need to be different when we actually use it, but this could work here. So this is pretty much a repetition of the previous values. Please do not do that. And please continue just creating rows, and then it should be 10 values, right? So yeah, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I believe these should just be added there as well. So that's pretty much it, I guess. The output. Output neurons. Yeah, and the probability is in percent. So instead of actually printing 0 dot something, we do it times 100, so we get a percent instead of spelling error there. Fix that. So this is pretty much that function. So that actually took care of calling each of these functions. So that's good. So now we only need to define the training network. Do a bit of separation there, so those are easier to read. Why? Yeah, we don't have the return statement. Yeah, of course. So let's look at the training function. That's a large one. Oh my god, here we have a lot of things to do. So let's start up here. We need a float value here. So these are easy. Those could be just defined as is. These delta values are actually float arrays, I believe. And the float array should be float and the output neuron size. And then we have the float for h delta, which is the size of all the layers inside. Oh, sorry. So we need to create new deltas. And then we need these temp weights and previous weights. And I think we actually define those above. And then we read some image goals for the training files. So this should be the actual that goes for each image from the file. Since it's malloced by the reader, we have the responsibility, of freeing its memory after training. So I believe these goals, we have to get back to those later, but I think that we can remove this for now. And here we need to check the image is less than the least mean square error. So I think we just need to remove these definitions and say here that we want, let's see, I think this is math abs. So it should just be above, and we can remove this function. So even though it's lower than we take the absolute value, so it will always be positive. So here we need to push all of these down a bit in the stack. I don't like when things aren't aligned correctly. So let's see here, we populate the input from the counter through all the training files. So here we need to actually get the training files. If populate input is false, then we will system out print line. And I believe that this never got any faults, so it's a void function now. So then we don't have that problem actually, so we can remove this. We still need to actually run it, but I believe we can skip this. And let's look into this file. We'll take a file name and run it through and get the data. So let's just comment out this code and put here read data from image file and populate input. So I think we will actually wait with this implementation until later, because I might want to change how this is actually done. I think that instead of in training files, I want to add a list of files to read. I can change that up, but I think we should go through this function and translate that first. So here we get the particular goal for each file, and I think that this should also be populated up here. So let's comment that out as well. Now we calculate the network for each iteration. So here we have a for loop with all the outputs, and we will check the target. Let's say the target is 0 just to get less of an error. So we go through all the output nodes and check if the current value that we want to hit is not the value. Then we will do this calculation here to correct or create a delta that we can use for correction later on in our network. So output delta at, this function we need to change a bit. So this is delta at out. So I think we will translate each of these first. Delta output at. So let's see, here we have those. So in our case, delta output at should be just this array, right? So we have, it's quite easy for us. We just need to use this array for the actual values that we want to. And we have doubles up here. What? No. Let's translate those to floats. No. I see. These values should be floats as well, which simplifies things. There we go. And the error is a float as well, so this translates quite nicely. So that one was easy. So let's continue and translate all of the different values that use this output delta at. So here we have a j value instead of a I value. And see if we have any more output delta at. We don't. So then we have put that value in, propagating. I wonder why there is so many spelling errors here. I'm not a native English speaker, but I've found that could be good to actually run things through a spell checker to help you out there. So let's see here. We have a hidden delta at. We have translated that one earlier. So this is the hidden delta at. Perhaps we haven't. Now that's quite easy as well, because it's just this value in the hidden delta array. So let's go back up here. So this is the hidden delta array. So hidden delta at should be in the hidden delta array. So easy to take the wrong value there. So then we add I, and this should be the hidden layer, and that should be 0 then. So that's the first translation, and then we just continue this hidden delta at, same here and the same here. So that we have translated now, and I think this is pretty much the same function that we had earlier. We just change the actual, or the same kind of translations that we had earlier. The only difference is the different numbers. So here, let's see that we didn't do anything stupid over here. We didn't. And here it's actually +1 -1, which is just 1, and a k value. So there we get that one. And lastly, we have the same value as above. And it takes the hidden value at. Okay. And does a dir sigmoid on that and times that with the hidden delta. Yeah. And then we get to this, and here we have also the hidden delta at, but in this case we have 1, which means 0, so we can remove these altogether. So it's just a j value, the hidden delta array. And input to hidden. Let's see here, what's the problem here? Yeah, input to hidden. It's input hidden. Why have you changed the order? Is it just to change things up to make it more interesting? Stupid. So input to hidden is ij for some reason. They want to change that up. Yeah, inputs is the outer layer, okay, and then we have to do that as many times as the layers, yeah. So that makes sense. It's still a bit strange to type it that way. And we have hidden delta at down here. So let's look at that again. So this should just be this function with the twist of hidden delta and then we take the k value here and the I value over here. That makes us, gives us the correct value. Hidden to hidden? We can't use that either. This one is a bit more to change up. So from hidden to hidden. Okay. This is just a direct translation. And see here. Hidden to hidden is the first input layer times the hidden neurons. So that's the first row of hidden. And then we take, so that's the translation between hidden and the nodes. So that's the weights between there. So we have taken that layer off. And then we take the I value, which starts at 2, minus 2. So that's from 0 and so on. And does the hidden times hidden. So that will give us the weights row, or actually it will give us the right matrix. And then we take J to get the actual row of weights, and then K for the actual value in the weights. So this is to calculate all the weights in the hidden to hidden layers. And it's a quite involved method. So let's tidy these up a bit. I like to have less space between things just to get a better overview of what's happening. So you can have more lines in each segment. Because often each line does not have that much functionality in it, and with as much comments as we have in this code, it's very verbose to have one extra row for each or for loop. So now we only have one extra value that we haven't translated here, I believe. Output delta at, did we remove that one? Hidden delta at, I think we did. So let's look at the neural, no, it was in this function, output delta at. So that's just the simple output delta array and the mapping into that. So let's see here, output delta and the I value in that one. And here we have hidden to output. This is the function for that. So I guess it's like the one above, but simpler, because we just, the I value is the maximum value here, so we want the last matrix in the function. So here we use J, because that's the inner loop, and then I, because that's the output value. So this should be the function for this. And then we do a counter, some more counter values. We reset the counter. We have a specific print F for the Windows environment, because I don't know. And then we have some break logic for the epochs, and some freeing information here that we are not required to do in Java, and we will increase the epochs. So let's just say that we don't have any printing here. We just say that if we end up, if epochs are larger than 1000, then we break. Easy like that. So we don't care to do more than 1000 epochs. Perhaps we will change this value to be even smaller. So one epoch is when you go from the input layer all the way to the output, calculate that. Then you will calculate backwards to see how much of a change you need to do to improve the network, and then apply that change over the network again. So that's one round of calculation, and that is required to do many times. I think that statistically you should do it at least 500 times, but the more times you do it, the more exact the match from the inputs to the output you get. So if you train the network too much, that is actually bad, because then you will get a too close match between the input values and output values. So you want a close match but not a perfect match, because then it will not be as good with new inputs that it haven't seen before. So now we have translated all the functions in this file. We haven't taken care of the reading of files, and we haven't tested our code. And I think we have at least less errors in this class. Not sure if we can compile it. We can look into that. Let's just try and make cannot start compilation. The output path has not been specified. Okay. So I think these are quite. Cannot start compilation. Yeah, I will look into these different problems I have in the build environment until the next time we see each other. And then we will continue to look into reading image files and actually testing our training and see if we can train a network and get a viable result on a specific image, see if it can recognize a number. So this should be really interesting to look at. So I hope that you found this episode interesting and that you learned something from it. Some of them mathematics and so on have just been copied, and we haven't really looked into exactly what each of these translations does. And I think that further on I need to do a lot of refactoring to make the code more readable. And now we have just done a one-to-one match from the C code. And if you like to see more of these videos, please subscribe to the channel. If you have any comments, please leave them below and share this episode with your friends and colleagues. And I really hope to see you in the next video.